All right, welcome. So thanks everyone for coming. So this is our Edison Science Lecture, and our speaker today is Tord Wingren. Tord is a scientist, inventor, and an entrepreneur. So sort of three things all in one. Holds 28 patents in wireless technology, and then also in lighting effects on human bodies. We all use Tord's scientific output every day. So my watch is communicating to my phone via Bluetooth. And so Tord will talk about Bluetooth, as well as also his new invention on brainlet. So please introduce Tord.
Thank you so much, Jonathan. And I must start to apologize that I have so many wires on me, because I normally don't have that. But I thought it was maybe not possible to do something else in this kind of environment. So I will actually start with giving a little bit background of myself. I started off in early 1980s with my studies in electronics, and I did a lot of laboratories in my father's cellar, but simultaneously I also grew up with two elderly brothers who were very much into medicine and did a lot of research and studies in physiology. So my main background is really in electronics, and when I started with Ericsson, which was my first job, it was more of integrated circuits. So I was like a pioneer for doing integrated circuits, and especially for radio circuits. So it's the whole first 20 years I was with Ericsson was very much into mobile phones, and since I've always been very interested in trying to understand how technology is going to be used, I think it's been very important to actually try to be close to the usage of the technology as you're actually a part of developing. That is something I have brought with me when I have also been part of the different other startups the last 20 years. And I will now start to tell you a little bit about the radio and the history where I was involved in. And maybe you have seen these kind of phones. They were very bulky in the beginning. So we started with that portable phone to the left. In the middle we had we call it pocketable, but you needed really big pockets at that time. And then we did everything we could to miniaturize the phone. I had a very tough boss at that time because it was all about doing the smallest phone possible. And what he did when we had made our first prototypes was to take a bucket of water and put it in the water and look into see how much bubbles were coming up. And if it was too many bubbles, it was the wrong phone design, and we had done a bad job. But finally we came into something very small. So this was kind of the winner. It was, as you can see, it's just half a pencil size. It's a very, very small phone. The problem with that phone was it was almost impossible to use your fingers to actually operate the phone from. So it was not the best sellable phone, but we actually won the size battle at least. However, later on the race of multi-communicators was coming on. This is early 90s when the mobile phone should have more functions in there. First of all, I must tell you that my boss and our boss, they never liked that we should have any games in the phone. That was totally prohibited. So that was also part why Ericsson didn't succeed very well in the mobile phone story, because we were not really allowed to do more fancy phones with a lot of games and other things in there. But we call them multi-communicators. This was the nomenclature we used before the smartphones, and it was basically the same principle. You had often like a pen on the side, and it was touch screens. but they were quite simple anyway. However, when Bluetooth was coming along, it was around 1993, 1994, we had really a lot of problems with all the cords going from the mobile phone to the headset to the computer, and it was really much of a mess when you have such a nice pocketable phone to have so many cords around you. So we had to put a number of axioms into that in order to become successful with a technology which we couldn't be alone with. We have to talk to other companies, of course, as well, but we had to start with something just to prove the concept. So it was all about doing a cable replacement, of course, but it should also be able to handle both voice and data. It should address a global footprint, and which means that we had not so much to choose between, because we couldn't go to licensed band, we have to go to unlicensed band. So it's at 2.4 gigahertz, it's right in the microwave band, which was already at that time popular band for that application. Of course, it has to have very low power consumption, and the range at that time was specified to 10 meters. And the most challenging was actually how we could get it down in cost to have it as a very low cost solution, which meant, of course, that we have to have very advanced integrated circuits. And it was actually this device where we went from bipolar solutions to CMOS solutions and did the whole solution in CMOS. Interoperability was a big thing which was driving Bluetooth to the industrial standard. We couldn't just be alone, of course, with doing this technology. And what's also important for the success was that we couldn't have too many applications to start with. It was very important to select some limited set so that we could early get out with the products and make sure that they actually work. On the protocol side, we had a lot of thoughts how to make a protocol which was scalable, so we didn't have to remake the whole protocol just by adding more applications later on. So we were thinking about profiles very much. And so usability was also, of course, very, very important. And I think many people who use Bluetooth has had a lot of pairing problems. It didn't really work so well in the beginning. Today, I think it's very much a user interface question, not so much about the real protocol and what Bluetooth actually can handle. And this specification was 94. In 2001, the first commercial devices came out. So it took 7 years before, from the first specification to actually the first commercial devices. And of course, we had prototypes in between. But what was very, very important in this success story was that we have to discuss with other parties who could help us to be our partners in this. And to be able to do that, we had a lot of patents. The other companies had also a lot of patents, was that we had to have a business agreement in terms of how we should actually do with our patents. So we put all patents in a big what do you say, bottle or bowl, and we had then a concept of everybody joining our Bluetooth alliance was actually going to to agree on not fighting each other. So that was a very, very important thing, and we had then a total number of adopters at that time was not so many. Today there are 35,000 actually companies who are involved in Bluetooth and has adopted to the whole standard. In 2010, the first Bluetooth Low Energy was introduced. That was a major update of the whole protocol. And right now, as speaking, there is a launch of some new very, I would say, advanced functionality, which is related to how you can use Bluetooth in labeling, when you have labels out for example, in Walmart, and the labels for each piece of goods, and the label is actually able to respond back as well, and it can be updated very easily. It's a broadcast protocol, but with a response mechanism and going back. Another very interesting part of the development of Bluetooth has been to include also angle arrival identification, which means that it's much more possible now to do higher accuracy distance measurements with Bluetooth, going down to 10 centimeters, which can be very useful for indoor positioning. So this was, you can say, the first the roadmap of it. And if you look into a bit closer in the typical max ranges today, we went from the 10 meters starting with up to the 240 meters today. So it's a huge development when it comes to the distance, but also when it comes to the maximum connection speed. So there's a lot of both basic changes to this protocols which has been done, but also the implementation when it comes to the radio itself. Maybe you wonder a little bit about the name of Bluetooth. I just want to say some words about that. I mean, Bluetooth, Harald Bluetooth was king in the Nordics, mainly in Denmark, but also parts of Sweden. And the thing was that it was just meant to be a working name. It was Intel, IBM, Nokia, and Ericsson, which we formed the first group of companies. It was very hard first, by the way, to convince Nokia to adopt to Bluetooth, because they wanted to go their own way. But we had a number of meetings, and the meetings between engineers to engineers never worked. We had to go up one step above that, because it was much easier to agree on a business level, actually. So that was what happened. And if you recognize Ericsson, Nokia, IBM, and Intel, they have all blue logotypes. So we thought Intel, when they came up, it was actually Jim Cardick who had read a history book from the Nordics about Harald Bluetooth. We thought it was an excellent working name, but that working name never changed. So it became really the name for the standard. So there is a special interest group there. But I mean, what was really the driving force behind the standardization of Bluetooth was the need, of course, for interoperability. And we had a lot of plug parties, as we call it, where different vendors are coming and seeing whether they can actually communicate with the other vendors' devices. So it was mobile phones to notebook computers, it was wireless headsets, and we know that the car stereo is also a very big application. But now we have many, many more applications all around. Actually, I skipped the first slide. I should go back to that, because I was now going to go into a little bit about the size of the market, because Bluetooth is today 4.9 billion devices sold during 1 year in 2022. It's amazing how big it is, and 38,000 companies have adopted to this spec. Brainlit, as we're talking about, is really scale up today. It's a company which I formed in 2012, and I will go more into it. The number of bulbs, if we just look at that, was 7.5 billion. So there is a big, you can say, market for light sources, and I will come more into that during the biocentric light presentation. But today we know that the biggest problem as we see is that there's so much static light around us, and as I will talk about here, that's a big problem due to that it's so unnatural to be exposed to static light during a whole day, for example. So almost 100% of all the light bulbs today has a non-dynamic behavior and is not changing spectrum at all during the day. So that's an opportunity, as we see. And going forward to that part of the presentation, I would first like to start with what are the fundamentals to Bluetooth and now BrainLit. Well, first of all, I think the timing is very important here. BrainLit was founded in 2012, just at around the same time as the light-emitting diodes became more ubiquitous. The blue LED Nobel Prize was 2014, for example. Bluetooth was specified in 1994, when phones were pocketable and really needed to get rid of the cords. But both started, I would say, with a unique idea addressing really a significant problem. For all startups, you are many here in the startup community, I think it's so important to think about how big is your problem. Not thinking too much about the innovation. The innovation is very important, how the unique is and how you should protect it, etc. And that has also been part of the BrainLit story, journey to very early on protect the basic technology. It's also important to say that building a solution fast, just prototyping it, selling it locally, getting frank feedback from users in a very early phase is super important. There's so much good, valuable feedback as we get when it might be your neighbors, it might not only be your friends, it might be guys who are really trying it out early on. Because that's how you can go back and have a coffee with them or whatever and really find out how is your solution working. And you really want to have the frank feedback and try to understand how your technology is going to be used with your users. On Bluetooth, we focused on very selected application, as I said. And it's a challenge to sometimes limit your concept to very few applications. Very many people want to do as much as possible. Don't think like that in the very early beginning. Think of focus. The most important is to have an outstanding team of people. That's absolutely the most important. I'm also an investor, actually. So I have invested in, both my time and money in a company where I can just give it as an example where the main founder, he wanted to be the sales guy himself, but we understood he was really not good in selling. But he didn't accept that, and we were suggesting 10 different guys, and he just threw them out all the time. And we lost 2 years just due to that. And it's unfortunate. I mean, everybody in the team has to have an open attitude when you're building a company. And to build with people with complementary skills is very nice. And it's also important that you can have fun together. A laugh now and then is really important. And of course, as in Bluetooth, we had many complementary experts. We have people in the really hard radio protocol side, but also in the implementation of silicon and understanding of the process technology and how that could be used for Bluetooth. And of course, you have to have a let's do it and no prestige mentality to be successful in that. Otherwise, you will fail, I would say. Very often you do that if you have too much prestige in what you actually do. And it's nothing wrong with failing. You learn a lot by failing. I have done it quite a few times, and it's a great learning experience. Of course, it's very important to attract fund for growth, but use it very wisely to scale innovation to products with social and biological impact. We also try to act fast, but stay agile and smart while you have to use evidence-based technologies to build on, and then we try to also avoid hierarchies in our company. And then I must say, of course, if a thing like Bluetooth, a thing like lighting, biocentric lighting, we need partners. We cannot build every bulb in the world. We cannot build every device for Bluetooth either. It's totally impossible. So you have to find mechanism where there's a win-win scenario for everybody, and that's why the business model is so important. So let me talk a little bit about biocentric lighting and what that actually is. The vision is that we should be able to get healthy lighting 24 hours during the day, but during our life, from the cradle to the grave. And I think it's really, really important. Where is this then coming from? Well, it's coming from, I got involved in the scientific community by being invited to a number of researchers who presented papers on what static lighting actually was, the impact of static lighting on our biology, by being exposed too long with that, which you actually are if you are in elderly care, if you're sitting maybe in education, sitting every day home or every day in a lecture hall. You have to be exposed to natural light. We have 10,000 generations of human beings being outdoors. Today we spend less than 10% of our time outdoors. 10% of a day is 2.4 hours. How many of you spend 2.4 hours? I don't know, but it's definitely very necessary to have a great dose of a natural light every day. So very early on, we looked into, I will actually talk about that part first here, is we looked into how the daylight spectrum looked like, and we know how fluorescent spectrum look like just by looking at the spectrum, a static spectrum here. We understand there's a big difference. It's a no-brainer. And we also know that there's been a number of developments both in LED and in the finding of this biological clock in every cell in organic material. We human beings, we have one biological clock in every cell, 24 hours running, and these clocks are very important for the hormone systems as we have. The most well-known is the melatonin and the cortisol, but there is a number of mechanisms which has been studied within the area of chronobiology. So here we saw the possibility, and we did very early on establish a scientific base for biocentric lighting. It was extremely important to have both all the different science groups aligned to what we actually are doing. And we know that circadian lighting, there are companies out there doing circadian lighting, but we are specializing in understanding of the model of the biological clock and how the biological clock is actually working for different people. So it's very important to collect data, of course, to make that model better and better. We have more work to do that, to do individualized, optimized lighting. But this is what we are working on. And so the first years, it was the foundational patterns for it. It was related to collecting data and be able to generate light recipes based on these data. and the second part of that was how the fundamentals of the system itself. Later on, we have we did the first, you can say, product to the market in 2015. We developed a little bit more during 2016 to 19, and at that point we had about 20,000 users in our system. So you could say that was more reference customers here. You know also what happened after 2020. This was the COVID period. It was a bit tougher to come out there with a solution and get people to use it. But we have, during this year and the next year, this year actually launched new products. And to make it much more simple to actually buy our products and get access to them and install them in a much simpler way. And since COVID was coming, I was lucky that we had a patent already in 2016 how to make a disinfection solution based on UVC. And that's the solution which took roughly 3 years to develop and get certified. So it was a lot of work and a lot of talk with the certification, United Laboratories and so on. They didn't have a standard for doing that because it's a total autonomous device. So we needed also to develop the standard together with the certification authorities. And today we're seeing we have school and sports sets. We have a number of, you can say, light products, which is very good for different applications. So let me just say a little bit about the basics. The eye. Sorry, I should point here. As you know, the rods and cones everybody knows about. In 2002, the third receptor was discovered, called the retinal ganglion cells, and they are necessary for catching the daylight and giving the right signal into the brain. So there's basically two main paths from the eye into the brain. One is for the visual center, the other one is for hypothalamus, where the master clock is. So we have a master clock in the brain, needing light, sending the right clock signal to the different parts of the body. And if we don't get that, if we don't get the dynamic light, the light which is where we have been exposed to for so many years, we will get a problem with sleep deprivation, which is one of the first things which happen. Light is necessary for good sleep. And sleep is very important for a number of factors. We know that long term we get more of immune suppression. If we have a good sleep, on the other hand, we have a much stronger immune system. And there is a number of other effects. I won't go into all of this, but there is a lot of studies supporting these statements. And here we are seeing that it's a big number of scientific papers. There's more than 2,500 papers which are supporting these statements. So internally we have this master clock, and here we can see that for different organs in the body we have a need for understanding the clock cycles. I mean, it's as you probably know, medicines today, you cannot take a medicine at any time during the day. It's actually meant to be taken at a certain time of the day. We know that about 20% of our total genome, I mean, we have around 5,000 genes. 20% of them have a light relationship. And this master clock is called the SCN, the suprachromatic core nucleus, and all humans have a natural rhythm of just above 24 hours. But without that synchronization, we get the problem. The thing is that there is also individual variations which are fairly large. We have different sensitivity to light when it comes to melatonin suppression. We have different chronotypes. Some of us are early morning people, some are late day people, etc. So it's not so that there is a very close distribution. This is fairly big, actually. It could be many hours difference here. And the thing is that this distribution is coming from very early time when we had to look after our family when we were in the cave. Somebody had to take care of the fire, somebody has to guard the children, somebody has to make sure that we were getting some food, etc. So people inside the family, they were actually having different sleep patterns. And we know today that these genes, as we have, they are, or even if we know that when growing up, when we are like 15 or 18 or so, we might be more of evening to night persons. There is a genetic inheritance for which kind of chronotype we actually are. We also know that the dim light melatonin onset variation, which means actually how fast will the melatonin actually start to raise after you have been exposed to light, and that can also be quite big difference. But the normal thing, what people actually need is about 3 hours before going to sleep, you should have a melatonin raise. So all of these factors, there is also an age factor. We know the pineal gland, which is responsible for the melatonin extraction, is having a variation over time, depending on the age. So we're taking all these factors in, and many more, when we're building a biological model for how we should be able to expose more optimally. But the first thing which we want to happen, I actually talked about this before, it's about 2,600 peer-reviewed papers, scientific papers, which are supporting the statements here to a very large degree. And what is then the outcome of all that is now that a new standard is coming along, and this standard is now going to be released in the end of this year, early next year, just for circadian lighting, which means that trying to avoid static light and having a light which is actually dynamic during the day and following the clock. This is something which is now more and more supported by the industry as well. So what is then the driving force between standardization of biocentric lighting? Well, I would say it's definitely the need to guarantee quality and quantity levels of healthy light from a wide variety of light sources. So to establish an interoperable network also for future personal health services where healthy light is an essential component is a possibility. And therefore we see the standardization very important. We see that some of the success factors to be able that this is really going to happen is to build a whole ecosystem of partners, supporters, and ambassadors, and forming these industry alliances where we see the overall goal to set new standards. To build a standard is not easy, and that's why you have to be generous and think very much about what is your business model for your IPR. And of course, the whole product sale should focus on professional human use to deliver true customer value. Otherwise, it won't take off. I think it will be too much maybe to go into all what the standard is and what kind of levels it is, so on, but I just want to say that to set the standard you have to have metrics and you have to have measurement capabilities so that everybody is measuring in the same way. That's of course basics, but the piece in the puzzle there is really to get the certification authorities or organization to be able to do this as an accredited service for the industry. I can talk a lot about light and reason to overperform, but I think you might be more interested to understand, to see what could the benefits be with the biocentric lighting. And there are a lot of individual benefits which has been proven in different studies. The cognitive performance in schools and so on has increased by huge numbers, 10% in mathematics, by the way. So it's a fantastic outcome, I would say. We are seeing the improvement in deep sleep and also the length of sleep, quality sleep, going up quite a lot. And there is a variation, you can say, in athletic performance during a day, which is 26%. We're not saying that we are going to hit that number always. We're hitting lower numbers, but the variation during a day between peak performance and trough performance during a day, there was a big, huge study in more than 1,000 athletes showing that the variation is so big during a day, which means that if we know when a certain performance is going to take place, if a match is certain going to happen at 8 p.m. or some time when you normally are almost in dark and where your melatonin levels are starting, then we can help that with light. Light is not something which is, light is very easy to work with when it comes to that. We see a lot of organizational benefits because we are selling business to business. So we look at their productivity and how they measure productivity. We come up to levels like 10 to 20%. And important today is, of course, also that we look into how can we save energy by our system. Because the problem and challenge here is that you need quite a lot of light as well to have a healthy dose of light, but that's not during the whole day. And of course, we have to have a combination being able to give you a good light for reading, etc., for the visual light. So we have done a lot in terms of professional sports. I think, Kyle, you could have been talking much more about that one than I can, because I'm coming from our Nordic and Swedish region, but I know we have so many customers here. Maybe you want to say some words about that later on. But we have got fantastic results out of studies done by Aura rings. We're using them as a biosensor to get data before and after. We're looking at activity, readiness, and sleep. And the team has made great progress, and this has been going on for up to 6 to 8 weeks, and we expect that this has been just increased even more if we did even longer studies here. So this is something going on in which we are very interested in order to get data. Of course, professional sport leagues and so on, they are interested to share a lot of data with us. So it's very beneficial to have that set up. I should say something more about the system, because I'm really a system guy, but just as a simple thing, maybe you've heard about human-centric lighting and biocentric lighting is our term, and human-centric lighting has no real definition. It's a marketing name being used for dynamic light, a light which is changing during the day, but not really taking into account the biological aspects. It's rather trying to follow a color curve of the sun. It's a light that is adjustable and dimmable, etc. But what we do a lot is that we have taken a lot of data for natural daylight. We're not saying that we are identical to daylight, but we are mimicking it as much as we can. And that's what our studies is showing, that we are able to do that. We are looking very much into providing and building a system which can take into account the individual need and being able to personalize it by improving both the light recipes from extracting the individual data, but also thanks to that we have now getting more and more luminar and light sources in so that it could be more portable. We're not yet there. You see an example of our Alvin standing here. So it's not very portable, I would say, but that's something which we are working on, making that specific light more portable. But we are coming up with a new solution where built on switches, which is just using the power from the finger and using Bluetooth beacons for that. So it's just a capacitive generator where we are not needing any electrical or battery at all. So you can move that and put your switch wherever you like it. You can have how many you like. And we are having one central box which is capable of infinitive number of luminaires being attached to that. So it's a scalable solution. You can buy a very simple package, and by buying that package you can just add more luminaires and afterwards if you like. So this is just a picture of a very simple installation with in an elderly care center in a table like that. And what we do when we sell this is that we also guarantee the health effect, the light dose as you can get from this when sitting during the lamp. So we have a number of solutions, customized solution being built into the location, which can be fully tailored to the customer needs. The sets are pre-designed, pre-configured, it's totally plug and play, and then we have Alvin. In addition to that, we have also the disinfection system, as I touched upon before. Most important is, of course, customer satisfaction and customer feedback. So we're trying really to follow up all our customers, and getting feedback is, as in all businesses, as we are around, super important. And this was one of many statements as we got, but since Sony is one of our biggest customers, this was of course a fantastic statement from them. And very early we have installations. I mean, this is a 112 center, 30 meters down under the ground, and they had installed our light. And the biggest problem they got was that they had a number of plants which never grow. They had a huge problem to get the plants to grow, and they didn't know that when they actually switched to biocentric lighting, these plants actually grow up very fast. So they complained to us. Well, it was of course a joke, but they were really giving that feedback to us. So extremely interesting to also see that effect. We hear some of our customers, some of the other universities as well. Sacramento Kings, we have American Eagle Outfitters, New York Jets, etc. I'm not familiar with everybody here. New York Institute of Technology has it, and many more, and some bigger companies like Ernst & Young, Airbus, etc. And here you can see some of the installations as well. I would like to talk a little bit. I think I have a few minutes left, right? So I know you also want to hear a little bit about my view on the importance of IPRs. I mean, IPRs is basically covering patents, trademarks, and design. And as a small company, you cannot have too many patents. You have to be selective because it's expensive. But having patents which is really covering your fundamental parts of ideas when it's unique is something I really recommend. It depends also, when you're applying for a patent, it's very important that you think about what are you going to do with it. And I used to say there's normally 4 aspects of this. One is, of course, obtaining revenue, if you can license it and sell it. But another one which has been important in Brainlit, for example, has been raising capital. If you don't have any revenue, you at least have patents and you have something you can show your investors. The third thing is, if you believe that your idea is so good that you can build a global standard of it, I think it's hugely important to have patents. Because then you have something to trade with and you have something to show up and where you can collaborate between other companies, with other companies. And the fourth one is maybe the most normal one, is to get the freedom to operate a position on the market, to block competitors, but often you're too small, you cannot chase other companies, but you can at least get the freedom to operate space, thanks to patents. So I think these aspects are how I look at it. I've been involved in licensing and standardization and see a lot of value in patents. But unfortunately, it's a lot of selections and decisions as you have to take. If you try to do it global on every market, it's too expensive. You have to select which market you think is most important for. So there's a lot of thinking which you have to do behind that. And now to my last last slide is actually where are we going with further? Because I think it's very important to never stop. I mean, the first patent we had was actually so foundational that it's covering the aspect of selling light as a service. And when it becomes more personal, when it's tied to both your history, the sleep exposure you have during the day, or the sleep pattern you had in 3-4 days or whatever, that all data is important when you are creating your light recipe. But the personal, in combination with the personal data, but also going forward, your calendar priorities. Are you going to travel? Are you going to train? Are you going to have a match day? Do you need the time shifting? And when do you want to have your bedtime? There are many, many factors involved in that. So that's how we see, at least, the possibility of giving everybody a service which is going to hopefully improve your life, all of you. Okay, that was it. Thank you.
Great, thank you. Any questions? Yes.
So you speak of when using it for training or in a game of Magic. So if you're an athlete and maybe you're on a strict regimen and you're sleeping, you go to bed at 9 and 10 p.m., you're waking up early the next day, but then once your game time comes, like if you're in American football, you've got games at 8 o'clock at night or 7 o'clock at night, they could run to midnight. So you're playing with what you're saying, I guess let me make sure I understand, is that you can induce a slight or use a slight, and you can stifle that rise in melatonin at night to increase performance at that later time if it's during what they would normally use for sleep.
What you actually want to do to increase performance, you want to actually keep the melatonin level lower for a bit longer time if you have a late match. So that's what you can suppress with light. But it must always be the individual's choice of how to use our light. But we have the recommendation for it, and we will be able to tell, okay, you can test it and you can try whether that really fits you. But we get very good results from that.
I'll put Oliver on the spot. Can you change the light?
Yeah, I was just trying to look.
While he's doing that, do we have other questions? Yeah.
I'll just yell.
Okay, perfect.
In the Bluetooth section, you mentioned selecting a limited set of applications to focus on for initial proof of concept. Can you tell us just a little bit what that process looked like within Ericsson at the time? How you define between handset and headset as being the primary thing we looked at?
Yeah, I mean, one of the things was that we had, for example, a session with IBM where IBM wanted to send very complex pictures, doing a lot of things in, having like a session with Bluetooth headset broadcasting from the very early on. But we found that these kind of application was quite limited at that time. So to prove a technology and to get acceptance for it, I think you need to target the real need of your innovation. If you can do that, get that attraction, I think people will say, then you can go out and test it as well. It's more difficult with those more complicated applications. The problem and challenge is, of course, how can you make sure that your protocol later on can be so flexible that you can also handle these other application areas. But I think we have seen the same thing with light. I mean, in the beginning, in our company, people wanted to use it for animals. We wanted to use it for plants. We cannot do all that, right? It was too much. And we have had very many people who want to be able to buy it from a consumer point of view. But being a small company, we have to address the business market first. So we have made those kind of strategic selections very early on in the company. And of course, you have to reconsider that. Was that the right decision? I think I like always that we should be able to challenge those decisions anyway 1 year later and say, okay, maybe we should open up for a change in our strategy. But it's important to do these strategic decisions quite early. Because if you just go on and hope that something, and then it can be very, very hard, of course, to make that selection.
Other questions? Did you get it to
Yeah, so right now we are on the Alv end using Bluetooth, brilliant technology, incorporated into Tord's new technology. To link it to the high-performance sports space, you could call this light recipe the post-workout or relax mode. So we're significantly suppressing cortisol, allowing melatonin to secrete for that down regulation post-workout or post-game. And on the other end of the spectrum, we have boost mode. So it might be quite hard, but that's why I try to pick opposite ends of the spectrum. Super intense blue wavelength light that stimulates a cortisol spike or a pre-workout or pre-game boost. They're short-term hacks or adjustment. And then the prescribed standard recipe is called auto-lit, which adjusts dynamically throughout the course of the day across various dimensions of light that are important to the retinal ganglion cells. And we work with high-performance organizations. We can customize those recipes depending on schedule, game time, and the like.
One advice I would like to also give you when it comes to startup and investment and so on, I mean, if we were to give the whole vision from the very start to the investors, sometimes it's not a wise thing to do. It's very important, I think, to have some short-term sales possibility, so you can actually attract early investors to see what they, to actually so they can see that you approve your concept. I think if we had told the investors the whole journey as we have been through now, some would not go in that early stage. It's often quite a long journey you do, but try to really focus also to get something out which gets proven. So we actually quite early we chose to do our reference design in off-the-shelf hardware and off-the-shelf luminaires. So it was not exactly what we wanted to have, but that's what we needed to get early out, and that worked actually. And I hope that will be applicable in your.
Yeah. Great. So I want to thank the Ideas Center for the sort of entrepreneurship aspect of this, and thank everyone for attending. Thank you.
Yeah, thank you. Thank you. Thank you. Thank you very much.